3.4, parallel and perpendicular lines. Now, if two lines are parallel to the same line, then they are parallel to each other. So it's almost like the transitive property. Notice right here, it says if A is parallel to B and P is parallel to C, then A is parallel to C. So it's, I think we can make sense of that as the transitive property. This one's a big one. If two lines are perpendicular to the same line, then they're parallel to each other. So if this one is perpendicular to T and N is perpendicular to T, then they must be parallel because they're intersecting that one transversal the same way. So we're always looking for, basically we're looking for two squares on one line, right? Two squares on this one line. Similarly, if two lines are parallel and if one line is perpendicular to another line, then M is also perpendicular, then this is true, right? So they kind of, when it comes to naming these, we'll just say things like, if two lines perpendicular to same line, we'll just say then two lines are parallel. And then this one here, we can be specific, kind of like that, if L is perpendicular to N and L is parallel to M, then N's perpendicular to M. Honestly, it doesn't really come up very often. Let's see, it says in the diagram below, A, B, and C are coplanar, so they're on the same plane. What conclusion can you make about lines A and B? Well, look, it looks like they're both perpendicular to the same line, so we could conclude A parallel to B. And let's just say they are both perpendicular to line C. Error analysis. Shiro sketched coplanar lines M, N, and R on his homework paper. He claims that it shows that lines M and N are parallel. What other information would we need? We would need to know that, right? They both have to be perpendicular to the same line. Distance. So the distance from a point to a line is always perpendicular. Like any other line would be a little bit longer. So the shortest distance from a point to a line is perpendicular to that line. And so we are going to be using this distance formula. We can call this D if you want. Remember, the distance formula comes from the Pythagorean theorem. It's x2 minus x1 squared plus y2 minus y1 squared. So find the distance from point A to line BD. Well, it's perpendicular right here, which is at that point. So we're going to apply the distance formula from -3, 3 to 1, -1. Oops. So what we're going to do is we're going to have, it's going to be, let's see, -3 minus 1 squared plus 3 minus -1 squared. So this is going to give us the square root of -4 squared plus 4 squared, which equals the square root of 16 plus 16, which is the square root of 32. And we could just leave it like that. You could do a decimal approximation if you want. Now we're going to try this one. You could try it on your own first if you want. We need to use E and G because you can see from point E to that line, that is the perpendicular length. So we've got -4, -3, and we have 1, 2. So the distance, or we could call it EG in this case, EG would be the square root of -4 minus 1 squared plus negative 3 minus 2 squared. So that would be the square root of negative 5 squared plus negative 5 squared, which equals the square root of 25 plus 25, or the square root of 50. And that's it. I think we're going to stop there. Perfect.